Hey folks, so in this video I want to go over two examples of using a stack. So the first one I have here is kind of the most trivial example. This is just a stack well, I'm not doing anything with it to be honest here, right? I'm just simulating it. But it's the first step to seeing how the mechanism works. So we already talked before about the rules, right? Basically add to the top, remove from the top. Keep things in order. So what does that look like? Well, on the left-hand side here, I have basically a trace of a stack. So you can see that initially I do this line over here. It says stack s equal new stack. Basically what that is creating a new stack. Naturally, a new stack is going to be empty. Okay, so we have an empty stack here. What I want to do basically is trace it out. So we're going to follow a bunch of different operations for push and pop and see how they change the contents of the stack. The reason we want to do that is so that we understand how this thing goes together, right? How does it act over time as I do those two operations? What does it look like? All right, so the first thing I do here is do a push, 5. Well, I have an empty stack. Naturally, I'm going to add it to the top. I don't have any choice here, right? Has to go there. This is kind of a trivial thing to do, right? So we create it, add one element. That seems good. Then we do a pop. Well, there's only one thing here, so we'll remove the one thing, right? The 5 has to go away. And really, I guess if you think about it, right, it should be removing the topmost element, but here I only have one, so kind of those are the same, right? The one element and the topmost element, those are the same thing here, so I'll remove it. So for top as well, we'll basically remove that 5 right now. There's nothing, right? We have just kind of the end. Notice here that I'm writing top. The reason I'm writing top is so that I know what is the end of my stack, right? Because the thing is, right, there's this end over here, and there's this end over here. I need to indicate which of those is the top. Otherwise, I might accidentally flip the directions of my stack, right? So I need to make sure that I know this thing over here is indeed the top. Moving along, our next operation is a push. So when we do a push, we're pushing on 1. All of a sudden, our stack looks like this, right? It grows, we add one element, we've pushed something on it, right? Now the top is moved up, right? The topmost element isn't just null or empty, it's the number 1. Let's do another push. We push to number 4, naturally our stack grows. So we have 1, 4, and 4 is our new top, okay? Another push. Now we're pushing 0. 1, 4, 0, right? Pushing, 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 right? We have this now stacked of 3 elements that we've grown up. Now we have right that 0 as the topmost element. Now we do another pop. Our another pop takes out the most recently added thing, which happens to be that 0. This, of course, leaves us with just 2 elements, the 1 and the 4, right? And 4 is now our top. And so there's this general pattern here, right, of stacks that somehow grow up and then shrink down. Grow up, shrink down. That's the general usage pattern you'll see in stacks. Now, stacks have tons of uses. Kind of one of the most common ones they have, right, is an undo operation. So I don't know if you guys ever thought about it, but when you're working in a text editor, right, you type stuff, hit Control-Z, you back up, right? Somehow that has the notion maybe of doing a pop, right? You're pulling back something, right? Or let's say you do like I think it's Control-Y, right, to redo. That's a push, right? You're adding something, right? Or you type something, you're adding something, right? So you can kind of go back and forth, right? You can add things, you can remove things, right? Control-Z and Control, presumably Y, right? To undo and then to redo, right? Or you're just typing, right? Back and forth. That can be very easily implemented inside of a text editor, right? Using a stack mechanic. Similar to that, right, is browser tab history, right? So you're browsing in your website, you're browsing stuff, right, and then you eventually get to a point where you want to go back. You click the back button. The back button again is going to be analogous maybe to doing a pop from a stack and going back. What is the last thing you visited? What was the last thing? Last thing, right? Going back, right? Same idea going on there. Another one, which we'll go into more detail, is basically on maintaining function calls, right? So your program runs. Your program has many functions in it, many methods in it. It wants to call them. Those methods or functions call other methods and functions. Here, we'll stick to the word we'll stick to the word method here. That's kind of a Java term. So we have methods. They call methods. They call methods. How do we track who called who? That's actually something that we can do with a stack. So let's actually talk more about that on this next slide. So this is an example of something called the call stack. And I've kind of changed the orientation of my stack here. It's no longer top to bottom, it's now left to right. So the top is basically over here in these pictures. So what's going on here? So what we want to do is basically figure out a way to solve the following problem. A program runs, a program calls methods. Methods call methods, and those methods call even more methods. How can I keep track of who calls who? Obviously, I need to do that because if I don't, I won't have a way to basically take data that a method computes and return it to the caller, right? There's some sort of sense of communication, right? When you do a return, you've computed something, you want to give it back, right? Who do you give it to, right? Give it to whoever called you, right? In order to kind of create that backward path, I need to keep track of who's calling who. Well, the way we'll do it here, and this is the way that all programming languages do it, is via a stack, right? And so a stack basically is used to record the different calls that happen. And so this actually has a specific name, and when you go into other classes, like for example, computer organization will tell you more, or maybe operating systems, basically the idea is you have a stack where every element on that stack represents a function being called or a method being called. And so let's just look at our diagram really quick. So our diagram, right, and this whole thing, right, is called the call stack, right? This is the call stack. Initially, right, let's say we call a function, like for example, factorial. We call it, when we call a function, we're basically pushing this function call onto this call stack. And the call stack has many purposes. The one we talked about right now is basically to know who calls who. It's also used to do memory allocation, which is kind of a more complicated topic. Now, over here, right, we've called factorial 3, and okay, that's all is good. And we're actually doing here kind of the factorial from earlier in the class when we talked about recursion, right? So recursion is the idea you have a function that calls itself. And so this function, this factorial function, works by calling itself, right? So factorial of 3 calls factorial of 2. And so actually, if that function were running, you'd basically make a call, and your call stack expands, right? So now I have 2 things on there, right? I make another call to factorial of 2. Factorial of 2 isn't done, got to do a call to factorial 1. So notice that as this function kind of executes, it's making more and more calls, and the call stack builds up, builds up, builds up until you get to the final top, right? So the final top over here, factorial of 0, is basically that last call. And if you think back to the recursive implementation of factorial, once you get to factorial of 0, you don't have to call yourself again. You can just return 1, right? You're done. You don't need to do any more work. And so you can take a step back. At that point, right, you can imagine you're doing push, 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 push for all the different functions that are being called. Now you can do pop. You can do pop, pop, pop. So you start with this one, pop it, and you basically give the result from it, which is 1, to the next method there on the stack, on the call stack. You do it again. Pass it, pop it off, pass it to the next one on the call stack. Pop it off and do the next one and pass it to the next one on the call stack. And each time, right, you're basically returning those return values, right? And they're building up, right? So they go from 1 to 1 to 1 to 2 to 6, right? So you're basically passing that return value backwards, right? And you're able to finish your computation. All right, so that's kind of an example of how the call stack works. Again, it's the idea of having this stack-like mechanism to keep track of who calls what. Because remember, only one method can be running at a time, right? So one method runs, it calls another method. How do we record that? We record that in a stack. All right, so those are a couple examples for how you use a stack. Hopefully that gives you guys a little bit more intuition for how they work.